Hello, pre-calculus students. We are going to continue and finish our lesson here on solving exponential equations with variables in the exponent. And we'll look at some more complicated examples in this case where you will have a little bit of a more complex or a complicated exponent here. So what we're going to do is just same as before, we're going to try to get everything down to the same base. Okay, so get the same bases on both sides. That's really important. Okay. So let's see, 64, I know that I can separate this into 8 times 8. Now you may be very tempted to say, oh, 16 is just 8 plus 8, that must be just as good. But we have to work with multiplication here because we're trying to solve for exponents, and exponents is repeated multiplication. So 16, well, what can we really do with this? Well, let's see, I can get this down to 4 times 4. And so this is, I'm just changing the 16 to 4 times 4, and this is 12 minus 2x. Okay. So now I can continue on a little bit further because, 4s and 8s, they have a common power. So each of let's start with the left side of the equation. So each of these 4s are just 2 times 2. So I have 2 times 2 for the first 4, and then another 2 times 2 for the second 4. All right. And so this gives me my base, and the exponent is 12 minus 2x. And over here, each of these 8s is actually 2 to the third. So this is 2 times 2 times 2. That will give me the first 8, and then another 2 times 2 times 2 for my second 8. All right, so now I basically have everything down into the same base, and I can really do some good work in simplification. So on the right side, that's 2 to the 6th power, and on the left side, that's 2 to the 4th in parentheses times 12 minus 2x. Okay. So keep in mind that this 12 minus 2x is one term. Okay. So now 2 to the 4th raised to the 12 minus 2x. All I really need to do is multiply that 4 through here. So this is 2 to the 48 minus 8x, and that's equal to 2 to the 6th. And you see here in this case, the bases actually don't matter that much. We just want to get the bases to be equal so that we can set the exponents to be equal. So because both of these expressions on the left and on the right have the same base, that's 2, we can extract the exponents and set that equal to each other, and now solve what is a relatively simple equation. Subtract 6 from both sides and add 8x to both sides, and then divide both sides by 8, so that you get 42 over x is equal to 42 over 8. We can simplify that down a little bit more. This is 21 over 4 as our final answer. Okay. So there you have it, one example of how to deal with a very complicated looking type of equation. Okay. I'm going to continue here. We have a complicated equation with exponentials and some fractions and some other things going on here, but rest assured we can certainly solve this. So on the right side here, I have a fraction, and on the left side I have a base that's not a fraction. So what I'm going to do is alter this 1/16 into 16 to the negative first, because really that's what 1/16 really is. And then on the left side, everything stays the same. And so now I'm going to skip a few steps forward here, just because I know you can hang with me here. That 16 is really 2 times 2 times 2 times 2. In other words, 2 to the 4th. That's not 24. That's 2 to the 4th. On the I should be more consistent with my parentheses. Here we go. So this is 5 minus 3x. Okay, so the bases are almost the same. They're almost equal to each other. We have 2 and 2 to the 4th, but using rules of exponents, we can multiply that 4 with that negative 1. So this is 2 to the negative 4th is equal to 2 to the 5 minus 3x. And now that the bases are equal, we can set the exponents equal to each other. So 5 minus 3x is equal to negative 4. Add 4 to both sides, you get 9. Add 3x to both sides, and that means x must be equal to 3. Okay, so we can certainly plug this in and check our answers as well. All right, so that concludes all of the examples we have here for this lesson over the course of the past couple videos. Be sure to practice these types of problems. Work on them without a calculator. The numbers here are small enough that you can do that. We want to exercise and understand these properties of exponents, not merely plug them into a machine. There will be plenty of time for that later. Thank you for watching and have a wonderful day.